Welcome to day number 4, video number 4, however you're watching these. Today is just about long division. Day number 4 of the AIM program. Let's get our branding in there. So day number 4, just about long division. So another one of these topics that you've done before and you've definitely learned in the past, but maybe you've stopped using it. So let's start using it, or let's kind of relearn how to do it and become familiar with doing it quickly. I personally in school, learned long division in middle school or whatever, and then kind of didn't really use it that much. I've found other shortcuts or other ways of dealing with the problems, but it's still pretty useful. I should have been using it more. I made my life more difficult than it needed to be. So yeah. All right, let's get into it. So from our previous day, we just talked about long multiplication. Hopefully you've done a number of those practice problems to re-familiarize yourself with this technique. But today will be for long division. No vocabulary to talk about, really, just some math. This one as well, the examples and practice problems are coming, exercises are coming from 2 different textbooks, so please make sure you're looking at the correct book. Everything's labeled clearly, just you gotta read the labels. Okay, so these first set of examples, there'll be 4 sets of examples total. The first one I've just made up myself for some simple numbers just to make it easier to explain things. And then the ones after this will be from the textbook. So first, long division. We want 48 divided by 3. So we write it like this, 48 and 3. And we're just basically splitting this up into separate problems. So we're splitting this up into, 40 divided by 3, and then also 8 divided by 3. But then 40 divided by 3, if it doesn't go cleanly, we have to kind of take the leftovers of that and then put that into this one as well. So that's basically what's happening underneath. Right, anyway, so our process here, take our number and we will kind of divide that into the smallest possible thing that we have here. So can 3 divide 4? Is 3 smaller than 4, basically? Can it go into 4? Yes, it can. How many times? Well, 1 time. 1 times 3. Let's erase that little there. So 1 times 3 would give us 3 here. So it goes in that many times, and then our leftover is this 1. We have, and this is in the tens position, so really it's 10. So there's 1 left over. Okay, so now we'll take the next number that we have, and we bring that down, and we combine them. So that's a 10 and an 8, so 18. Okay, so now we are doing the question, we're taking the leftover from here and saying, well, basically 18 divided by 3. So how many times can 3 go into 18? Well, it turns out that is 6 times. So 3 times 6, 18, goes in very cleanly. The result is 0, there's nothing left over. So, okay, we're done. So our result here is just 16. So that one divided in cleanly. Next one, see a few different things happening here. We will have 48 divided by 5. All right, so can 5 go into 4? Is 5 smaller than 4? No, it isn't. Okay, so we add 1 more digit and do that. So 5 into 48. Okay, well, so that's the original problem we're dealing with here, but this long division will help us figure out the decimal places. So 5 into 48, well, 5 into 50 would be 10 times, and this is 1 less than that, so that will be 9 times. So 5 can go into 48 9 times, which would be 45, and then we will have 3 left over. All right, so we're not done. We don't have a 0. So again, in the textbook examples, or when I learned this when I was much younger than I am today, they'd say, okay, well, the answer is 9 with a remainder of 3. But then any kind of math after middle school, like we don't care about remainders. That's not, like, we want the decimals, we want that accuracy. Certainly anything at the university level, I've never seen like, oh, let's talk about the remainders. That's not really useful. So we want the decimals, so let's be accurate here. So to get these decimals, we'll add a 0 here, so 0.0, and the answer will be 9 point something. Bring down our 0, 3 here, so 3 and the 0, so 30. So 30 divided by 5, 5 goes into 36 times. So 6, and then 5 times 6 is 30. So 0. Okay, so now we're done. So our final result here is 9.6. All right, so we have a decimal, but it's a precise decimal. It's exactly 9.6. The last one here, we're not going to get that level of precision. So let's actually do this. So 48 divided by 13. Well, 2 digits out front. We have to consider these together. So can 13 go into 4? Well, no, obviously. So we have to do 13 into 48. All right, so 13 times 2 would be 26, times 3 would be 39, but times 4 would be 52. So 13 can go into 48 3 times, but not 4 times, so that will give us 3, 39, subtract, get 9 down here, and not a 0, so we're going to get some decimals here. So I'll bring down this 0 here. 13 into 90. So 5 would be 65. 6 would be 78. 7 would be 91. So this is 90. 91 isn't going to work. So 13 times 6. So 13 will go into 96 times, and 13 times 6, 78. And so 90 minus 78 will give us 12. All right, still not done. Let's add another 0 here. Carry that down, 0. So 13 into 120. Well, 13 into 130 would be 10, and it's going to be 1 less than that. So that's a 9 here, and 117. And we subtract and we get 3. All right, still not done. Add a 0 here and do 0 here. 13 into 30 will go in 2 times, and 26. 4, yeah, no, okay. Not finishing, and this is just gonna go on forever. This will be some infinite decimal. So I'm gonna say 3 decimal places is enough. I got other things I need to do. So we'll say our answer is approximately 3.692. And then whatever else will come after that. Okay, so clean division with just an integer solution, no decimal, or maybe a decimal, but not infinite, or infinite decimal. Any one of those 3 things can happen. Long division nice tool that will help us figure out all 3 of those. Okay, let's clear this out, and 2 practice ones here. First one for me. All right, 189 divided by 4. I know I'm not going to have a nice clean integer result here, but I will not have an infinite decimal. Dividing by 4, it'll be 0.25 or 0.5 or 0.75, one of those. 4 into 18, that's 4, so that's 16 and 2, and bring down the 9, and that will go in 28, so 7 times, and 1, and not finished, so bring down the 0, and 4 into 10 will go in 2 times. Looks like it's going to be 0.25. That will give us 8 here, subtract, and that's 2, and there we go. Bring down the 0, 20, that goes in cleanly, 5, 20, 0, so we're done. So our answer here, 47.25. Okay, so that's that one. The next one here, 189 divided by 9. 189 looks like a multiple of 9, so I think we're going to get a really nice clean number here. I can already see what it's going to be, but let's do the long division anyways. 18 divided by 9. So how many times does 9 go into 18 here? That's 2 times, and then 2 times 9, 18. Okay, 0, 0 here, but no, we're not done because we have more digits in the original number. So we'll bring down our 9 here. So 9 into 9, that's 1 time, obviously. And 9 and 0. Okay, we have a 0 here, and it's also the final digit. There's nothing left to work with. So now we are finished the problem, and our answer here is 21. Okay, last one, 189 again, divided by 11. This looks like it will not go in cleanly, and with 11 that means we'll have an infinite decimal, but it will repeat. We'll have 2 digits, and then that will repeat forever. Right now we don't know which ones, but we'll figure that out. But that's a pattern we should kind of be aware of and be looking for when we're doing this. So 11 into 18, that goes in 1 time. So 1 times 11, 11 here, subtract 7, and bring down the 9, 79, 11 into 79, well, 77. So that's 7 times, and that gives us 77 here. And that's a 2. All right, gonna need some decimals here. So 0, 11 into 20 will go in once. So 11, and that will give us 9. Bring down that 0, 11 into 90. Well, 11 will be 88, so 8 times there. All right, and that gives us a 2, and let's another 0 here. 2 gives us 20, and that goes in 1 time, and that gives us 11, so that's 9, and bring down a 0. That will go in 8 times, and that's 88, and that's 2 again. Okay, so hopefully we're kind of noticing the pattern here. 2, 9, 2, 9, 2. You can also see in our result 1, 8, 1, 8. So it looks like it's going to be the same thing. It's just going to repeat here. So our solution is 17.18 repeated. So 181818 forever. So that's not kind of a clean decimal, but it's still a nice result there. It's not some messy decimal that will just constantly be changing. So we can express it in this way, 17.18 repeated. Okay, that was my turn. So now Your turn. 123 divided by 3 and divided by 4 and divided by 7. Have fun. Okay, so answers here. This one, 123 divided by 3 is just 41. 123 divided by 4, this is 30.75. And the last one here does have an infinite decimal. So it was 17 points, and then 5, 7. You might have given up at this point and said, okay, two decimals is enough. And if you did, okay, 2, maybe 3 is usually enough. Depends on your circumstance, of course, but often that's enough. It does actually repeat, though, if we go up to 6 digits. 1, 4, 2, 8, and then that whole thing repeats. So it would be 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, ... So dividing something by 7, you will get an infinite but repeating decimal. And if you go up to 6 digits, you'll see the repeating pattern. There's a little more we could notice about it, but I'll leave that for you to explore on your own. But if you look back at what we did 2 days ago, some common patterns and 1/7 and what that repeating decimal looks like, and then compare it to this one, and you'll kind of notice some similarities. Anyways. So those are the answers here. Again, if you just did like 2 or 3 decimal places here and you just said approximately, then that's fine. Excuse me. Okay, so those are the warm-up ones. Now let's get into the bigger ones. One set of examples like this with just a rather large number being divided by another smaller but still large number. If we understand our division concepts well, long division, then we should be able to do this. I won't promise it'll be fun, but should not be overly difficult. All right, so 74,521 divided by 241. Oh, all right. So 241 into 7, no, doesn't go. Into 74, also no, but 745, yes, that works. So how many times? Is it 2 or is it 3? We can just kind of write out some multiples here. 241, next would be 482, and then if we multiplied by 3, we would get here 23, and here we would get 723. Okay, so it looks like this will go in 3 times. So 241 goes into 745 3 times. Okay, and that gives us 723 here. So subtract that, and that will leave us with 22. Okay, so now 241 into 22. That doesn't work, so bring down the next digit. 2 here, still not working. Okay, so we have to bring down the next digit as well here. So 2,400, sorry, 241 into 2,221. How many times does that go in? Well, f times 10 would be 2,410, and then subtract 241 from that. It's going to be less than this number. So that looks like it will go in. I forgot to add the 0 here. So 0 and then 9 times. So we want 9 times this thing. So minus 2, 4, 1. All right. So if we subtract this out, then our results will be 2,169. Let's double check. 9 and 0 and 4, 6 plus the 1, 1, and there. 4 and 2. Okay, good. So that works. So 2,169. And we subtract those, and the number we will get here is 52. Okay, not finished. Let's do a few decimal places. This is probably not going to be some nice clean decimal result, but let's just do a few places and then stop. So 241 into 520, that will go in 2 times, and that will be 482. All right, and that will give us down here 38, and bring down this 0 here, 38. That will go in 1 time, so 241. All right, and that's 79, and we can add another 0. That would go in 3 times. And at this point I'm saying, yeah, this is probably enough. So this feels accurate enough. Let's say our result here is approximately 309.213. And then some more decimal places if we had lots of time. Okay, but often that's accurate enough. So even with some larger numbers, just kind of write out your multiples like this, and you'll only have to write out at most 9 of them. And because we're only dealing with sort of single digits up here. So at most 9 of them, but probably not even that many, and you'll be able to get your results. Okay, so long division with larger numbers. So 2 practice ones. First one I will do. We have 78,641 divided by 256. 256 is an easier number to work with. Sort of powers of 2, second multiple here would be 512, 768, 1024 times 4. Okay, so I won't write all of them out, but those might be handy. 1,280, I think we'll need to. Okay, so 256 into 7, no, into 78, no, into 786, yes. So that will go in 3 times, and then 768 here, and subtract. And we'll get 18. And bring down this 4 here. 256 into 184. Nope, that's 0 times. And then we'll have to bring down this 1 as well. So 1. And 256 into 1,841. All right. So let's say this is 256 times 5, so at least that much will go. Maybe 7 times? So this was 256 times 2, So let's try adding these together. 1280 plus 512. If we add these, that's 2, 9, 7, and 1. So 1,792. That's just a little bit less than this kind of number here, our target. So looks like it will cleanly go in 7 times. So 7 times 256, we just figured out 1,792. And if we subtract those, we are going to get 49. If we add a 2 there, 50, yeah. So 49. And not finished, so let's add a 0 here. Decimal, bring down the 0, 256 into that. That will go in 1 time. 256 into 34. And 256 into 340, that's also 1. 256, and that will be 84. 840, we already have these multiples figured out on the side. That will go in 3 times. But here I'm gonna say, you know, that's all right. I think I'm happy with this. So 3 decimal places, we'll say our answer is approximately 307.113, and then that's enough. Okay, so there is first example, first practice one for me. Next practice one is for you here. 76,461 divided by 248. The numbers are similar to what we've been working with, but they are not the same. Answers are not going to be the same. You do have to actually calculate them. Try to have at least 2 digits, at least 2 decimal places in your result. You don't have to go forever, but at least 2. All right, go ahead. All right, so here, result that I got was approximately, because I also did not do an infinite number of decimals here, 308.31. And I stopped after 2 decimals. So there's a solution here that's accurate enough for our purposes. So 308.31, whatever. Okay, so there is that one. And let's jump over to some other topics, 2 other things. So fractions to decimals, and then dealing with decimals in the numbers that you're dividing. All right, so fractions to decimals, this will be quicker. So if we want to do this, what is 5 over 8 as a decimal? Then we can use long division to figure that out. Excuse me. So if we do that, then that would be not equals here. So you might be tempted to write something like this. Well, 5 and 8. No. So this is 5 over 8. Our answer should be less than 1, or let's sort of ignore the negative sign for now. That's less than 1. So if we did 8 divided by 5, well, that's the same as, that's this, 8 over 5. But we want 5 over 8. So make sure you're writing your division here in the correct way. 8 is on the outside, 5 is on the inside here. Okay, so 8 does not go into 5, obviously. So we are going to need a decimal here right from the beginning. So 0. So 8 into 50, that does work. That goes in 6 times for 48. and we get a 2 down here. Okay, so add another 0 down here. 8 into 20, that's 2, so 8 into 2 times 8 is 16. So 4, okay, now it looks like we're going to be finished. 8 into 40, that's a nice clean 5. 40 and 0. Okay, so our answer here then, and we put our negative sign back in front, negative 0.625. That is our exact result. I know in the video from 2 days ago, I told you to kind of memorize some of these. I'm guessing you probably didn't or haven't fully memorized them yet. Even if you have, this is a nice way to practice long division. Just make sure you're doing the right thing divided by the right thing. It's a very useful method for converting fractions to accurate decimals. All right, next practice will be for me, 7/8. So if you remember the pattern, this will be a three-digit decimal. So 3 decimal places. So this will be 8, 7 divided by 8, and does not go into that. That's 0. So 8 into 70, well, that's 8 times for 64, and we get 6 down here. Okay, 0, 8 into 60. Well, that is going to be 56, so 7 times. And then 4, and hey, we have our 4 again, so 8 into 40, that's exactly 5, 40, and 0. Okay, so then we have, I forgot the decimal place up here, 0.875. So there's our answer, put our negative sign back up here again, negative 0.878. Nice. My 8 does not look very good. 8.75. Okay, one more here for you to do. This one should be pretty quick. So take a shot. All right. So once again, I really hope you are actually pausing the video and doing these on your own. I do not expect you to be able to solve it just in the amount of time that the little spinny pause symbol thing is there. It's only like 10 seconds. So like actually pause and then go on when you're ready. If you're not actually doing the work, again, you're totally wasting your time and there's no reason for you to be watching this. Okay. Answer here is negative 0.375. Hopefully you got the same number on your end. All right. And the last set of examples, I did say there were 4. So last thing, let me double check. Yeah. Okay, last thing we're going to do is dealing with division when we have decimals in the things that we are dividing. It's not making a decimal, but already having the decimals up front. So if we look at this here and here, what we can do, so let's just kind of take this and rewrite it as a fraction first. So this is negative 25.65 divided by negative 0.06. So that is negative 5.65 over negative 0.06. Okay, so obviously the negatives on the top and bottom are just going to cancel each other out. So that's that. And all right, so we can multiply like the top and the bottom by something and keep everything balanced, right? So let's just multiply the top and bottom by 100. That will get rid of the decimals that we have here. So that would be 2, 6, 2, 5, 6, 5, and then 6 on the bottom. So that works. We can, as long as we do the same operation on the top and the bottom, then our fraction stays balanced and our result will be the same. Just like 3 over 5 is equal to 30 over 50, which is equal to 300 over 500, like this. It doesn't matter which one of these divisions we do in our long division, we're going to get the exact same result. So it's a little easier to deal with things if we get rid of the decimal, especially the decimal in the bottom number here, the thing that we are dividing by. So now we have 2,565 divided by 6, and that looks like it'll be easier to deal with. You could do it directly with the decimals, but just you're reducing the chance of confusing yourself if you do it this way. So 6 into 25, that will go in 4 times for 24, and that's 1, and 16, 6 into 16, that's twice, for 12 with 4 left over into 5. That will go in 7 times for 42. And that will give us 3. So we're not done. We need decimals here. 6 into 30, though, that will go nice and cleanly. No infinite decimal in this case, so 30 and 0. OK, so our result here then is exactly 427.5. So we can do this division even if we had decimals in the original numbers. Just get rid of them and then do your division. Your answer will be the same. All right, let's clear that. Do the next one. So this is practice for me. If we rewrite this, this is the same as saying 23. I'm going to multiply both by 100 for 9.2 over 4. I could multiply by one more and sort of get rid of the decimal on the top here, but that's not really necessary. My goal is to have the bottom number, the thing we are dividing by, be as small and as simple as possible. That's what's going to make my operation the easiest. Wrong color. So 4 is dividing to 23,049.2. Okay. So 4 into 23, that's 5 times, gives us 20, and 3 here into 34 will be 8 for 32, and a 2 there, and 9, that will be 7 times for 28, and that's 1. All right, we got our decimal place here, but we still had a decimal, so not inventing a 0, we just use what is given. So 2, 4 into 12, hey, that's a nice clean 3, and we're done. I have an exact answer here. So 587.3 is our solution. Okay, so that's practice for me and practice for you. Go ahead. Okay, so solution here I got 34.25. Exactly 34.25. Just a note here, we are dividing by a number that's less than 1. So the result should be getting bigger. Like that's just sort of a pattern to notice. So this is kind of close to 4, and this is kind of close to 0.125, which we should recognize as 1/8. So it's kind of like we're doing 4 times 8. And then that would be 32, but it's like a little more than that and a little less than that. So a little different, but close. So just a quick look at the numbers, we can say our number should be around 32, 34.25. That sounds like the right kind of thing. If we had some number that was really small or whatever, then, you know, it's a quick way of just noticing, hey, we probably made a mistake. All right, right, that was the last one. So finish with long division. Well, finish with the video. Now you get to do some practice exercises. In our textbook here, so the pre-algebra book in chapter 1.5, just kind of, I don't know, regular long division with sort of larger numbers and everything. There's a whole bunch of practice questions here. And if you want to do some practice specifically with going from fractions to decimals, then, and actually in both directions, then here in the intermediate algebra book, chapter 1.4, in these practice questions here. Okay, that's it for today. So we just did a bunch of long division, long multiplication, last time long division, this time. Just some not maybe super exciting arithmetic methods, but core skills that everyone kind of needs to know and should be able to do quickly and fluidly. From our next day, we'll get to things that are a little more, at least interesting for me, prime numbers and divisibility tests and prime factorization. I like these because we can use these to sort of notice patterns and find shortcuts when we're doing operations, rather than always doing kind of the long, boring ways. So that's coming up next time. Hopefully you're looking forward to that, but do a bunch of practice questions first with the long division stuff. Make sure it's comfortable and quick for you. And then I will see you in the next video when we talk about all the prime numbers and factoring and divisibility tests. So thank you for watching, and I will see you next time.